The last module we have to talk about for our exam is Module 4, which is all about quadratics. So we're going to start off by simplifying negatives underneath the square root. So anytime we have a negative underneath the square root, we represent it using I. I represents the square root of -1. So I'm going to simplify the square root of -120. I can first write it as I square root 120. I can take out that negative part by using the I. I can now break down 120 like we did in Module 3. So I can break it down as 40 times 3. 40 I can break down as 10 times 4. 4 becomes 2 and 2, and 10 becomes 5 and 2. So I'm looking for pairs of the same number. I have a pair of 2's. So outside of my square root, I'm going to have 2i, and then underneath, I have to multiply the 3, the 5, and the 2 back together, and I'm going to end up with 30. We can do the same thing for the square root of -48x to the 5th y to the 10th. I can first write it as I square root 48x to the 5th y to the 10th. I can break down 48 as 6 times 8. 6 can break down as 3 and 2, 8 as 2 and 4, and then 2 as 2 and 2. So I'm going to have two groups of 2, which means on the outside of my square root, I'm going to have 4i. Next, I want to look at the variables. So if I look at x to the 5th, I need to know how many groups of 2 are in that. And there's going to be 2 groups of 2. In y to the 10th, I'm going to have 5 groups of 2. So then I have x squared y to the 5th. Underneath the square root, I'm going to have a 3, and I have 1 x left over from x to the 5th. So next we're going to look at operations on complex numbers, specifically adding, subtracting, and then multiplying. So just like when we were subtracting polynomials, the first thing we want to do is distribute the negative into the parentheses. So it becomes 3 plus 2i minus 4 plus 6i. Now I want to combine like terms. So we have 3 minus 4, which is going to become -1. Then 2i plus 6i, which is going to become 8i. So my final answer is -1 plus 8i. When we're multiplying complex numbers, we're going to use FOIL. So everything in the first set of parentheses is going to multiply to everything in the second set of parentheses. We're going to do 8 times 2, which is going to give us 16. 8 times 3i, which is going to give us 24i. -4i times 2, which is going to give us -8i. And then -4i times 3i is going to -12i squared. It's important to know that I squared is equal to -1. So when I simplify after multiplying complex numbers, not only do I need to combine like terms, but I need to simplify any powers of I. So when I do 24 minus 8i, I'm going to end up with 16i, but instead of -12i squared, I'm going to get -12 times -1. I can then do -12 times -1 and get +12, and then 16 plus 12 is going to become 28 plus 16i. And that's going to be the final answer. Next, we're going to take a look at solving quadratics. And the first method we're going to look at is factoring. In order to solve a quadratic by factoring, you have to be equal to 0. So x squared minus 7x equals -10. My first step is going to be to add 10 to both sides. So we end up with x squared minus 7x plus 10 equals 0. Now, to factor this quadratic, I need to look for the numbers that multiply to 10 but add to -7. And in this case, it's going to be -5 and -2. That's the only way to multiply to a positive but add to a negative. So we're going to end up with x minus 5 in one parenthesis and x minus 2 in the other. And we're still equal to 0. Now, in order to actually solve my quadratic, I have to take each parenthesis and set it equal to 0. So we have x minus 5 equals 0 and x minus 2 equals 0. Then we solve both of those equations. So I'm going to add 5 to both sides in the first equation. I'm going to add 2 to both sides in my second equation. And I'm going to end up with the x can equal 5 and the x can equal 2. Anytime you solve a quadratic, whether it's by factoring, completing the square, or the quadratic formula, you should always have two answers at the end. Next, we're going to take a look at solving a quadratic by completing the square. So our first step in completing the square is actually going to be to move our constant to the other side. So I'm actually going to subtract 11 from both sides. So we're going to have x squared minus 4x, and then we're going to leave a little room for when we find our perfect square, equals negative 11. To find the value that's going to make x squared minus 4x a perfect square, I want to do b divided by 2 and then square it. So in this problem, that means doing negative 4, dividing it by 2, and squaring it. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. You should always be adding a positive number to the left side. Because I've now added a number to the left side, I must also add that same number to the right side. That way we're not actually changing our quadratic. Now we want to factor the left side, and it's always going to factor as a perfect square trinomial, which means the same thing as both sets of parentheses. So we're going to have x and a number in parentheses with our squared. To figure out what number goes with x, you're going to do b divided by 2. So negative 4 divided by 2 is going to give us negative 2. Then equal, and then negative 11 plus 4 is negative 7. Now to get x by itself, the first thing I want to do is take the square root of both sides, because a square root and a squared cancel. So I'm going to have x minus 2 equals, in order to get two solutions when completing the square, you have to put a plus or minus in front of your square root. So we're always going to put plus or minus. Now I want to look to see if I can simplify my square root. So I'm looking at the square root of negative 7. I can't simplify 7, but I can take out the negative by putting an I. So I'm going to get plus or minus I square root of 7. The last step is to finish getting x by itself by adding 2 to both sides. And when I write my final answer, the number we've added to both sides, I'm going to put in front of the plus or minus. So we're going to have 2 plus or minus I square root 7. The last type we're going to look at is solving a quadratic by the quadratic formula. So it's important that you have the quadratic formula written down. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. In order to use the quadratic formula to solve a quadratic, you have to make sure it's equal to 0. So 3x squared minus 7x plus 1 is equal to 0. So my next step is to identify a, b, and c. A, b, and c are going to be numbers. They do not contain variables. So a is the number in front of x squared, which in this case is 3. B is the value in front of x, which is negative 7. And c is our constant, which is 1. Now I just plug in our values into the formula and simplify. So we're going to x equals negative, and then b is a negative 7, so I'm going to put it in parentheses. Plus or minus, underneath the square root, I'm going to have negative 7 squared minus 4 times 3 times 1. Then all over our denominator 2 times 3. So negative 7 is going to become 7 plus or minus. Underneath the square root, when I square a negative 7, I'm getting a positive 49. You should always have a positive value here, whether or not b is a negative number. And then 4 times 3 times 1 is going to give us minus 12 all over 6. Next, I want to do 49 minus 12, so we're going to get 7 plus or minus the square root of 37 all over 6. My last step is to check to see if the number underneath the square root can simplify. So the square root of 37 does not simplify, which means this is our final answer. I do want to briefly talk about the discriminant because it is related to using the quadratic formula. So the discriminant is specifically b squared minus 4ac. What the discriminant can tell us are the types of solutions we have to a quadratic without performing the quadratic formula. So we have four options. We can have that the discriminant is greater than 0, and it's a perfect square. We can have that the discriminant is strictly greater than 0. We can have that the discriminant is equal to 0. And lastly, we can have the discriminant is less than 0. So when the discriminant is greater than 0 and it's a perfect square, that's going to be two rational solutions. So what that means is you end up with a number underneath the square root that's a perfect square, like 36, 16, any of those. It's going to simplify. You're going to end up with either two whole numbers, two fractions, or a combination of that for your solution. If it's any other positive number, that's an example of two irrational solutions. So that would be an example of what we just did. We got 37 underneath our square root for our discriminant. That's just a number greater than 0. It's not a perfect square. That tells me that the square root is still going to be part of my solution. Next, we can have the discriminant equaling 0. That's going to be one rational solution. What that means is you're going to just end up with negative b over 2a when you do the quadratic formula without the plus or minus. And lastly, that's if our discriminant is less than 0. That's going to be two complex solutions. So that means I'm going to have a negative number underneath the square root. I'm going to have I in my final answer. So in our next problem, I can solve the quadratic by any method. So we have x times x plus 3 equals 3. So the first thing I need to do is get it into a form that looks like a quadratic. So the first thing I'm going to do is distribute the x into the parentheses. So we get x squared plus 3x. Then I need to subtract 3 from both sides, so it's equal to 0. Okay. So the first method I always like to check is factoring. So in this case, I would be looking for numbers that multiply to negative 3 and add to 3, which do not exist. The only way to multiply to 3 is 3 and 1. There's no way for 3 and 1 to add to 3. I don't really want to do completing the square because when I do b divided by 2, I'm going to get a fraction, and I want to avoid fractions with the completing the square, which leaves me with the quadratic formula. That's going to be the best method to solve this quadratic. So I have to identify A, B, and C. So A is going to be 1, B is going to be 3, and C is going to be negative 3. If there isn't a number in front of x squared, it's just 1. It's not x squared. When I plug these values into the quadratic formula, we're going to have x equals negative 3 plus or minus the square root of 3 squared minus 4 times 1 times negative 3 all over 2 times 1. Now I'm just going to simplify this expression. I have negative 3 plus or minus underneath the square root. I'm going to have 9 because 3 squared is 9. And then 4 times 1 times negative 3 is going to give me a negative 12. But I'm subtracting, so it's going to change to a plus 12 all over 2. When I add 9 and 12, I get negative 3 plus or minus the square root of 21 all over 2. I cannot simplify the square root of 21, which means this is my final answer. Next, we want to take a look at a graph of a quadratic. So given a graph of a quadratic, I want to be able to identify x-intercepts, y-intercepts, vertex, and axis of symmetry. This is something that you're going to use Desmos for on the exam. So typically you would be given an equation, graph it in Desmos, and pick out that information. But I'm going to go ahead and label all of these things in my graph. So the vertex is always either that lowest point or the highest point in a quadratic. The y-intercept is where it crosses the y-axis. And then the x-intercepts, which we're typically going to have two of, are where it crosses the x-axis. Then lastly, the axis of symmetry is the vertical line that splits your parabola in half. So it's going to go the vertical line through the vertex. So if I go ahead and write all of these as points, my x-intercepts are at, if I look at my scale, they're going to be at -1, 0, and 3, 0. It's important to look and see how the scale is on your graph so you can figure out if each space represents 1 or a half. The y-intercept is going to be at 0, -3, and it is important that you write these as points. The vertex is going to be at 1, -4, and then the axis of symmetry, it is an equation. It's always going to be x equals the x value from your vertex. So in this case, that's going to be x equals 1. It is important that you write the axis of symmetry as an equation. It does need to have that x equals. Number 38, we want to know the vertex and axis of symmetry for the quadratic y equals 2x squared minus 4x minus 3. So what you want to do is we want to check this with your graph. So if you were to take that equation and graph it in Desmos, you would get something like what I have in my picture. So you want to identify the vertex, which is going to be that bottom point. So that means my vertex is going to be the point 1, -5, and my axis of symmetry is going to be the equation x equals 1. On 39 and 40, we're using the same equation. In 39, we want to know the x-intercept and the y-intercept for the quadratic x squared plus 2x minus 9, and then in 40, we want to convert it to vertex form and then state the vertex. So what we want to do for 39, in order to figure out the x-intercepts and the y-intercept, we want to graph it. So we want to take x squared plus 2x minus 9, and we're going to put it in Desmos. And when we graph that in Desmos, we're going to find that the y-intercept is going to be at 0, -9. For our x-intercepts, there are two of them, and in this case, they are not nice values. What that means is they're decimals, which is fine. So what we're going to do for the x-intercept is we're going to write them as decimals. And we're going to write them as decimals using all of their decimal places. So our first one is going to be at -4.1620. And then our second one is going to be at 2.1620. Next, we want to convert our quadratic to vertex form. Okay. So vertex form is y equals a x minus h squared plus k, okay, where hk is the vertex. So what I'm going to do is convert it to vertex form algebraically, and then I'm going to use the graph to check that I have the correct answer. So when we convert a quadratic equation to vertex form, we do a partial completing the square. So I want to figure out what would make x squared plus 2x a perfect square. So I have to do the 2 divided by 2 squared. So 2 divided by 2 is 1, and 1 squared is 1. So I have to do plus 1. But I've now added a value that changes my equation, so I also have to subtract 1, and I still have the minus 9. What we want to do is we want to pay attention to this quadratic, the x squared plus 2x plus 1. That's going to give us the perfect square part, which is the part that's in the parentheses. So we're going to have x, and then to figure out what goes in the parentheses, we have to do 2 divided by 2, which is going to be plus 1. And then outside of the parentheses, I want to combine those terms. So negative 1 minus 9, it's going to give me negative 10. I've now put my quadratic in vertex form, and I can now identify the vertex. When you're identifying the vertex from vertex form, the x value is the opposite of what's in the parentheses. So because I have a plus 1 in the parentheses, I'm going to have a negative 1 for my point. The y value you keep the same. So the negative 10 on the outside is going to stay negative 10. I am going to check all of 39 and 40 with the graph here in just a second, but just make sure you have all of this written down. So if I look at the graph here, I've labeled, which is what you should get when you graph it in Desmos. I see that my x-intercepts are at the negative 4.1620 and the 2.1620. I have my y-intercept at 0, negative 9, and I have my vertex at negative 1, negative 10. You can also, given the vertex of a quadratic, put it in vertex form, but you can also do it algebraically. So that's all we have for the midterm review for Algebra 2. Please let me know if you have any questions over the Module 4 or any of the other parts we have done.